This lesson will provide 2 examples on how to evaluate indefinite integrals using the method of U-substitution. Looking at our first integral, we have the integral of sine x divided by cosine to the 4th x dx. Because we have cosine x raised to the 4th power in the denominator, we will let u equal cosine x, and therefore differential u will resemble the numerator of sine x. So if u is equal to cosine x, then du is equal to the derivative of cosine x times dx, which is negative sine x dx. So because we can substitute u for cosine x, the denominator can be written as u to the 4th. And notice we're left with sine x dx, not negative sine x dx. And therefore, let's divide both sides by -1 to solve for sine x dx. This gives us negative du equals sine x dx. And now we can substitute negative du for sine x dx. Writing the integral in terms of u, again, sine x dx is negative du. Let's factor out the negative. And because u is equal to cosine x, the integrand function is just 1 divided by u to the 4th. Next, let's write this as negative, or the opposite of the integral of u to the power of -4 du. And now we can apply the power rule of integration. The antiderivative is negative u to the power of -4 plus 1, which is -3, divided by -3 plus c. Simplifying and writing in terms of x, we have positive 1/3, and u to the power of -3 is really cosine x raised to the power of -3 plus c. Let's write this using a positive exponent. This is equal to 1 divided by the product of 3 and the cube of cosine x, or cosine cubed x, plus c. And let's write the antiderivative using big F of x, where big F of x is equal to, again, 1 divided by the product of 3 and cosine cubed x plus c. This is the family of functions whose derivative is equal to the given integrand function. Looking at our second example, notice how we have a double angle in the numerator and a single angle in the denominator. Let's first perform a substitution for sine 2x, where sine 2x is equal to 2 times sine x times cosine x, and therefore we can write the numerator as 2 times 2 sine x cosine x, which gives us 4 sine x times cosine x in the numerator, and the denominator remains 8 plus cosine squared x. Now this one's a little bit tricky. From here, we're going to let u equal the denominator of 8 plus cosine squared x, which I'm going to write as the square of cosine x. And now du is equal to the derivative of 8 plus the square of cosine x times dx, which is 0 plus 2 times cosine x to the first times the derivative of cosine x, which is negative sine x. Notice here I'm applying the chain rule and then times dx. And now looking back at the integral, since u is equal to 8 plus the square of cosine x, we can write the denominator as u, and we can see we're left with 4 sine x cosine x dx, and we have du equals 2 cosine x times negative sine x dx. Let's first write this as du equals negative 2 sine x cosine x dx. And here we have a choice. We can multiply both sides by -2, so that the right side matches what we have in the integral, or we can just solve for sine x cosine x dx. I'm going to be consistent and solve for sine x cosine x dx by dividing both sides by -2, which means -1/2 du is equal to sine x times cosine x dx. So now we can substitute -1/2 du for sine x cosine x dx and factor out the 4. So writing in terms of u, we factor out the 4. And then again, sine x cosine x dx is -1/2 du. So I'll factor out the -1/2. And then we have du. And since the denominator is now u, the integrand function is just 1 divided by u. Simplifying, we have -2 times the integral of 1 divided by u du. And the integral of 1 divided by u du equals natural log absolute value of u plus c, which in our case gives us negative 2 times natural log absolute value of u plus c, which in terms of x is negative 2 natural log absolute value of 8 plus the square of cosine x, or 8 plus cosine squared x plus c. And again, we can label this big F of x. We can actually also drop the absolute value here because cosine squared x is always positive and 8 is also positive, which means we can write big F of x as big F of x equals negative 2 times natural log of just the quantity 8 plus cosine squared x plus c. It's not wrong to leave the absolute value, but in this case it's not required. I hope you found this helpful.